Hello guys. So today I'm going to tell you about Python generators. So Python generators are different than Python iterators. If you don't know what an iterator is, please see my previous video on this playlist. You'll get to know what a Python iterator is. So now let's come back to Python generators. So before moving on to Python generators, let's see a very important statement in Python, which is yield. So what yield does is it simply suspends the function state. It simply suspends the function and returns the value to the caller, and then it saves the state of the function in its memory, so that when the function is called next time, it resumes from there. Okay, so let's define, we want to have a function which will generate the square of elements. Okay, and how? So when that function gets called first time, it will generate the square of say 2, then for next call 3, next call 4, and so on. Okay, so let's define the function. mm, get square. Okay, it will have an x. So what it will do, it will yield x into x. Okay, and then now x will be x plus 1. Next function call resumes here, and yes, sorry, it should be inside a loop. Okay, we can use the infinite loop, or you can have a limit here as well, that while the x is less than this, you can execute this function. Okay, so this is the function we have. Let's see, print get square. Let's start from 2. So it is returning right now as a generator object. Let's convert it into a normal object. So see here what we are doing. We are calling this get square method with an initial value and storing it in a I variable. So as long as this is true, it keeps on going. So let's see. So I have um, used a condition here because I have not used a condition in the function. If I don't use this condition, it will end up in an infinite loop. Let's run this. See here, you can see, so when during the first call it stores the 2 and returns the value of 2 into 2, then the next iteration, the next function resumes from here, and we the x is changed to 3, then again yield x into 3, then 9 is returned, and so on. This is how it gets executed. So this is function usage of yield. Yield statement is very useful if you want to have a split if you want to have a split execution. I will show you how to use multiple yields inside within a Python function a little later in this video. Now let's move on to the generators, the Python generators. So the basic difference between an iterator and a generator is, while iterator is a class object, generators are function. And while iterators uses return as a return statement to get the value, the generator uses the yield as a statement to get the value. Okay, so let's use the same function as a generator. Here I have defined a as a generator object for this function. Okay, now let's print. Next, next. Just execute, it should return 4 and 9. Here you can see 4 and 9, 4 for the first call and 9 for the next call. You can implement the same using iterator also, but iterator, as I told you, iterator is a class object which stores the variables in the memory, while generator only this in generator only this function is stored in the memory along with its state, nothing else. Okay, in an iterator all of those objects along with functions get stored in the memory. Cool. So let's deep dive more into generators. We can directly define generator objects instantly, and this is really cost efficient. I mean to say, time efficient. I'll show you how. Let me tell you first how we can define a generator object directly. And enter to for num in range of 5. Okay. Now if I print the AA, it should return me a generator object. See, in generator object. So the AA is now a generator object which I have defined dynamically here. Now let's call it AG and define another list using the same. So now we have a list and a generator object. Sorry. See the generator object and the list. Now let's compare the performance. Okay, increase the size to 5,000. Similarly, increase the size to 5,000. Let's clear our previous things and import this. Cool. Cool, that's fine. Let's take it down. Now let's see the comparison. Print sys dot get size of object. Call this EG. Again print sys dot get size of L. Cool. So guys, the output here will represent the size of both these objects. Let's run it. Here you can see. So a generator object is taking only 128 bytes while a list object is taking 43 kilobytes. This is a big difference. That's why generators are mostly used in Python for faster processing. Okay, let's move on and see how you can use multiple yield statements within a Python generator function. So as I told you, we can use multiple yield statements within the Python generator. So the next execution will start from the last executed yield statement. Let's take a look. Let's take a multi-sample method. While true, print first first. Let's keep it simple. Okay. Rather than printing here, I would say yield this. Okay. Then again yield. Again string. So now let's define a generator object for this function. Multi-sample and print next of A. Similarly print next of A. Another print. So you can use multiple print statements here because the while loop is there, which will generate infinite iterators. As you can see, first statement, second statement, first statement, second statement. So if you have a list on which, suppose you have a list of integers and you want to process a method for even numbers and process different method for a single for odd numbers, then you can call a function for that even numbers, and then in the next yield you can call the method for the second iteration. This is how about Python generators. Please like and subscribe this please like this video and subscribe the channel. Also, if you are not sure about Python lambdas and Python generators, please watch my previous videos. Thank you for watching, guys.